Hello, I think I am audible. Okay. Okay. Hi all. I guess I'm audible and my screen is visible to you all. I think everyone can hear me, right? Okay. Thank you for that. Okay, let me start. Welcome all for this session. This is a tutorial session for the subject or the course Analog Circuits. The topics that we'll cover is of week 1. So Analog Circuits by course instructor Professor Jayanta Mukherjee from IIT Bombay. I am a teaching assistant. My name is Narayanan. I was called from IIT Palakkad. So I'll be assisting you in this course. So basically the tutorial session will be covering a few questions or problems regarding the same, like whatever the topic has been covered in the week 1. Based on that we'll I have collected few questions, and based on that we'll have this session. So I will just solve few questions, and it will be helpful for you to understanding that basics, as well as it will be helpful, definitely will be helpful for solving assignment questions also. So let me start. So this week I think in week 1 sir has covered the basics of pole zero concepts and basics of op-amp based circuits, adder, subtractor, and inverting, non-inverting configuration. Also I think the introduction on the differentiator, integrator and all. So I have collected some 10 questions and solved that, and I'll discuss that initially. And before starting, let me tell, like this Google Meet link may end within 1 hour. So like that is the timing. So just after correct 1 hour, this will end. But you again join the same meeting link through the same meeting link. I will be again joining. This entire session is for 2 hours. Okay. So please do that after 1 hour. So let me start. This is the first question. So the first question, let me read the question. Determine the poles and zeros of the following transfer function: T of s equal to s plus 3 by s minus 2 into s plus 4. So it's a direct question based on poles and zeros concepts. So I think you would have gone through the sir's sessions. So as we have seen there, any transfer function, the poles and zeros of any transfer functions are that like the solution of numerator and denominator. So what is the concept? The concept is like the values of s for which the transfer function T of s goes to infinity. So whatever value of s we substitute in this equation at which the transfer function goes to infinity, that values are the poles. So as we know, like if the denominator is equal to 0, definitely the transfer function value will go to infinity. So so what is the poles? Poles are the values at which the denominator function is equal to 0, or the values of s at which the denominator function becomes 0. So those are the poles. So so from here, from the equation itself, we can find like what is the value of s for which the transfer function becomes 0. That is for s equal to 0, s equal to 2, this s minus 2 will be equal to 0, and for s equal to minus 4, the transfer function becomes 0. Not transfer function, denominator will become equal to 0. So 2 and minus 4 will be the poles of that function. Similarly, zeros are the values of s. Okay, zeros are the values of s for which the transfer function becomes 0. So that is when the numerator becomes 0. So what is the value of s for which the transfer function or the numerator becomes 0? That is s equal to minus 3. So this will be the zeros. Okay, so this is the solution. So transfer function, we know T of s equal to s by s plus 3 by s minus 2 into s plus 4. So as I mentioned, zeros are the values of s at which the numerator T of s becomes 0. So as I mentioned, s will be equal to minus 3. At s equal to minus 3, the transfer function T of s will be 0. So zeros is minus 3, and poles is s at which the denominator of the T of s becomes 0. That is when s minus 2 equal to 0 or s plus 4 equal to 0. So s equal to or s equal to minus 4. So this is a solution for the first question. It's a basic question. I guess it is clear. We can have the question, or if you have any doubt, you can interrupt me, or else we can take it at the end. Okay. So let me come to the second question. It is also a question based on poles and zeros. So the question is, determine the poles of system. Determine the poles of a system and determine its stability. Okay, so we have to find a system's poles and the stability of the system. Okay, and it is given like the Laplace transform of the input of the system is x of s equal to s square plus 4s plus 8, and the output of the system is y of s equal to s plus 1. Okay, so the question is like we have a system. And its input is being given as x of s, and the output is y of s. Okay, and it has been given given that to find the poles of system and its stability. So from this itself we can say like how to find this. We have to initially find what is the transfer function, right? The denominator of the transfer function will be value of s at which the denominator of the transfer function is equal to 0. That is a pole. So we will find what is the transfer function of system. So we know transfer function T of s of a system is equal to y of s by x of s. Okay, Laplace transform of output by Laplace transform of input, that is T of s. So initially we will find what is T of s. So from here itself, y of s equal to s plus 1 and x of s equal to s square plus 4s plus 8. Okay, so the values, so the question is to find poles. So we just need to find the solution of denominator, the values of s at which the s square plus 4s plus 8 is equal to 0. Okay, and that value will be the pole. So let us see. So this is the solution, that is T of s equal to y of s by x of s equal to s plus 1 by s square plus 4s plus 8. So we need to find the poles. So we will equate the denominator to 0 to find what is the value of s at which is equal to 0. So s square plus 4s plus 8 equal to 0. So you can either find the solution by the same method through which we will find the solution of a quadratic equation, that is minus b plus or minus root of b square minus 4ac by 2a. The same equation you can apply here. I have done a similar way, that is s square plus 4s plus 8. So I will just split 8 into 4 plus 4. So this term is s plus 2 whole square and plus 4. So if I just can convert this to a square minus b square, it will be more easy, right? So I just 4 is equal to 2 square. So in order to get minus, I will just add j. So minus 2j whole square. So 2j whole square is minus 4. Minus minus, it will be plus. So these are same. These two are same. Okay. And this is a square minus b square. So a plus b into a minus b. So a plus b, a is s plus 2, b is 2j. So s plus 2 plus 2j into s plus 2 minus 2j. Okay, so the poles. So this is sure. Hello. Okay. Wait. I think. Okay. Wait a minute. I'm sorry. Okay. Many are in waiting list. Sorry. Okay. I think I have admitted all. Yeah. I have admitted all. Okay, thank you. Okay guys, so I was discussing about this question to find the poles and stability of this system transfer function. So So if anyone is in the waiting list, whoever mentioned the same way, you can kindly remind me. Means there is no notification coming here. So thank you for that. Okay. So we were discussing about how to find the stability of the system and the poles of the system. And so for that we found initially. Okay, I think someone has come here. Wait a minute. Okay, let me admit them everywhere. Okay. Okay, so okay. Okay, I think it will be better to be in this way. Okay, sorry for that. Okay. Okay, I think everyone has been admitted. Okay. Okay, so okay, so by solving this, we will get s plus 2 in s as this. Okay, so on solving this, it is similar to a square minus b square. So a plus b into a minus b. So this can be written as a is s plus 2, this one, and b is 2j. So s plus 2 plus 2j into s plus 2 minus 2j. So what are the poles? Poles will be minus 2 minus 2j and minus 2 plus 2j. So these are the poles. So these are the poles. So that is what the question asked, right? Determine the poles of the system. So the poles are these. Now the question is to determine the stability. So how to find the stability of a system? So like for example, if we have a transfer function t of s, how to find its stability? Stability is we can determine if we know the poles of that system, where the poles of the system lies on the sigma and j omega axis of like s domain axis. So we know if this is sigma and j omega. So what is sigma and j omega? S is always written as sigma plus j omega. So this is actually s. So okay, so this is s. So wherever, like if the value, if the value of s, not value of s, the poles of s. So say if the poles of s lies on the left hand side, that is this side of j omega axis, the system will be stable. And if the values of s lies on the right hand side of the j omega axis, it will be unstable. And if a pole lies on the j omega axis, it may be partially stable. Like it may be stable, it may not be stable, but usually it is like partially stable. So for example, if we have a pole on j omega axis and I have two poles on the same point on the j omega axis, mostly this will be unstable. So that's why it is partially stable. It may be stable in certain condition. So so in order to find whether this system is stable, we just need to know where the poles lies. So if the poles lies on left hand side, it is stable, right? So we will see that. Okay, so the poles are minus 2, minus 2j and minus 2 plus 2j. So the real term is minus 2. So definitely it will lies on the left hand side. So this side, right, left hand side. So this is the poles, minus 2, this is minus 2 plus 2j, and this is minus 2, sorry, minus 2j. So definitely the poles lies on left hand side. So the system is stable. So let me admit a few more candidates. Okay, yeah, I have admitted. Yeah. Okay, so the question. So we have solved the question, like what is the poles of the system and its stability. So the system is stable. Okay, I guess it's clear. I think almost all rest of all the questions dealing with poles and zeros can be easily analyzed using these two questions, I guess. So that's all on poles and zeros. We'll start with the third question. The third question is on op-amp based circuit. So I will read the question first. The question is, consider an op-amp based summing amplifier shown below. and the question has also given the values of the components connected to this that adder or summer. So R1, R2, RF values, and V1 and V2 is also given. And the question is determine the current through feedback resistor RF. So the question is to find what is the current, feedback current through resistance RF. So what is the feedback network here? The feedback component kept is the resistor RF. So this is the feedback component, and what they have mentioned is to find what is the current flowing through this RF. So say we will denote as IF. Okay, so we have to find this. So since nothing has been mentioned about op-amp, whether it is ideal or non-ideal, we can consider this as an ideal op-amp. So for an ideal op-amp, what is the input resistance? Input resistance is infinity, not approximately, it is infinity. So if the resistance is infinity, the current through from non-inverting to non-inverting terminal is given as 0 ampere, right? So there is no current flowing in this direction. So what is IF? IF is a current coming from this input terminal, that is the current through R1 and the current through R2. Say current through R1 I denote as I1 and the current through R2 denote as I2, which means the current IF will be equal to I1 plus I2. So current IF will be equal to I1 plus I2. So this is the feedback current. So question is to determine what is the value of IF. So in order to determine the current IF, we can find what is the current I1 and I2, and we can just sum it up. Okay. So how to find the current, each current R1, current through R1 and current through R2. So as we mentioned earlier, the input resistance is very high, which means there is no current from this direction, inverting to non-inverting terminal, there is no current, which means whatever is the voltage here, that is the voltage here. So this is 0 volt since it's ground, so voltage here will be 0, right? So what is the current from V1 to this node? V1 to means current through R1. The current through R1 is the voltage across R1 by that resistance. So V1 is the voltage, right? From this point to this point, voltage is V1 and 0. So V1 minus 0 is V1 by the resistance R1. So V1 by R1 is this current, and the current through R2 is similarly like this point voltage minus this point voltage. So V2 minus 0. So V2 by R2. So this is the current. So V1 by R1 plus V2 by R2 will be the current I1 plus I2, and that is the current flowing through RF. Okay. So that is what I have solved here. So current I1. So as I mentioned, I1 plus I2 is IF. So I1 is equal to V1 by R1, that equal to, so V1 given is 4 volt. So V1 is 4 volt and R1 is 2 kilo ohm. Okay, so 4 by 2 to 2 milliamps. Okay, kilo, so milliamps. Similarly, I2 is V2 by R2. So V2 is, the voltage given is 2.5 volt. So 2.5 by 2.5 volt by the resistance R2. R2 is 5K. Okay, so it will be 0.5 milliamps. So what is IF? IF is the current I1 plus current I2. So 2 plus 0.5, 2.5 milliampere. So the net current through RF is equal to, IF is equal to 2.5 milliampere. Okay. So this is a question. It's a question related to adder. Okay, so let us go to, let me check anyone has entered. Let me admit them. Okay, I'll admit all. Okay, I have admitted. Okay. Okay, so we are dealing with the third question. The third question was a summing amplifier, and they have given two voltages V1 and V2, and we need to find the current through feedback resistance, and we have found IF as equal to 2.5 milliampere. So coming to the next question, the question 4, consider an op-amp based summing. It is the same question, see the same question as previous. So consider an op-amp based summing amplifier shown below, and the question is to determine the output voltage V0. So it's very easy, like initially we have found what is the current IF, right? So what is the current IF? We have found IF as equal to 2.5 milliamps. So what is the voltage V out? V out is the voltage across the resistance RF. Since this node is 0 volt, so whatever is the voltage across RF from this point to this point, that is a voltage V0. Since the current IF is flowing in this direction from this point to this point, what is the polarity of voltage across RF? It will be like this. Entering point will be plus and the leaving node will be minus. So say if I mention this as voltage across RF as VRF, the voltage VRF will be polarity will be like this node plus and this node minus. So but what is the voltage V0? So what is the voltage V0? The V0 is the voltage between this node and say there is some ground, means the voltage between this node and this ground, that is V0. So this ground is same as this one, right? This is also similar to ground, virtual ground. So voltage across RF, this point, from this point to this point, but the voltage across RF is plus minus VRF. So what is V0? V0 will be negative of VRF. So V0 will be equal to minus VRF. Okay, voltage across RF. So what is VRF? VRF is a voltage across RF, right? So RF, what is the current through RF? IF into the resistance RF. Okay, IF is the current. IF is the current that we got in previous question, that is 2.5 milli. Okay, minus 2.5 milli into the resistance RF given is 5 kilo. So 5k. So whatever is the value, that will be the voltage V0. Okay, so that is what I have solved here. So okay, V0 equal to minus IF into RF. IF is minus 2.5 milli into 5k, that is equal to 12.5 volt. So what is the output voltage of this summing amplifier? It is 12.5 volt. Okay, so what is the takeaway? Takeaway is like in summing amplifier, like for example, if this is a there are many number of inputs are there being connected. Okay, say I have connected other resistors like R3, R4, R5. Okay, and say this V3 voltage input, V4, V5. So how to find V0? The simplest way is to find what is the feedback current. Okay, current through RF. Since ideally speaking this is virtual ground, right? So we can easily find what is the current through each of these resistance. Okay, and that is like this voltage by this resistance, this voltage by this resistance, like that, and we can just add it, that is IF, that into RF, that will be the voltage V0. And the second takeaway is like this is the given input is given to the inverting terminal. You have to check that, like inverting terminal, and because of that the current also the current that is negative feedback, and the current is flowing in this direction. Okay, so the voltage drop V0 will be negative. So this is actually an inverting summer. So sir would have sir has explained that also. This type of summer is known as inverting summer configuration. Okay, so these are the two questions based on summer. Now let us I think it's clear. We'll go to the next question. Question number 5. The question 5 is consider an op-amp based difference amplifier shown below. So this is a difference amplifier, op-amp based difference amplifier, and the question is to determine the output voltage if V1 is equal to 6 volt and V2 equal to 4 volt. So in this question the values of the compounds, like each compound's values has been given. Okay, and also the voltage has been given. So we have to find what is the voltage V0. So in previous question we had all input and same at the same node, like at the same inverting node. But here then next input like V1 is given at the non-inverting node. So we cannot say like let me clear this. So we cannot say previously we how we did find the V0. We found what is the voltage or a current through the feedback, and the current is equal to this current, right? But here we cannot mention like this current is V2 minus this node voltage. So in previously it was 0 in the previous question, because there was no voltage connected here. But here in this question voltage has been connected, V1 has been connected. So what is the voltage? The voltage won't be 0 here. So we have to consider what is the voltage here. Okay. So the easy method, there are two methods we can find in many methods. The easiest method is to find through superposition theorem. Superposition theorem. So before coming to that, let me. So a few people are in waiting. I will just admit them. Okay. Okay, I have admitted them. Okay. 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 Let us come back to the question. Okay. So the best method is to find the voltage. Sorry. The best method is to find the voltage V0 due to V1 and V2 separately. That is by superposition theorem, and just add it. Like for example, first I will consider the voltage V1, and we will find V0 due to V1. So what we will do is we will just initially connect V2 to ground, and we will find V0 corresponding to V1 as V01. Later we will apply the voltage V2, ground V1, and we will find output voltage due to V2 as V02, and we will just sum both these voltages, and that will be the voltage V0. So this is superposition theorem, right? So we will do the same concept here. That will be easy here. So we will apply superposition theorem. So consider only V1. So V1 I have connected. The other node has been grounded, as you can see here. So Vt equal to 0 here. Okay, so what happens is this actually similar to non-inverting configuration, right? So we just need to find what is the voltage here. So if this voltage is V1 dash, if this voltage is V1 dash, what will the voltage V01? V01 will be V1 dash into 1 plus Rf by R1, right? That is non-inverting configuration. So 1 plus Rf by R1. This will be the voltage at V01. Correct. So first we will find what is V1 dash. So what is V1 dash? I'll just clear this. So what is V1 dash? V1 dash, see, as initially I told, we will be considering all this op amp as ideal. So the resistance here is infinity. So this network, this network is like a potential divider. Okay. So potential divider means if I apply voltage here V1, what is the voltage across at this point? This point means the voltage across this resistance, right? So voltage across this resistance means V1 into this resistance 10k by 2k plus 10k. Like if I have a potential divider R1, R2, and I have connected some voltage V. What is the voltage at R2? That will be equal to V1 into R2, V into R2 by this R1 plus R2. Net current into that particular resistance R2. So the same procedure we have applied. So V1 into this resistance R2 is 10k by 10k plus 2k. Okay, so this is equal to 10 by 12, right? So 10 by 12. So this will be the voltage V dash that I mentioned earlier, V dash. Okay. So what is V01? So this is V dash into 1 plus Rf by R1. Okay, Rf here is the feedback resistance is 10k. Okay, the feedback resistance is 10k. R1 here is this 2k. Okay, 2k. So that is what written here, 1 plus 10k by 2k. Okay. Okay, so that is 1 plus Rf by R1, and this is V dash, which we already calculated here. Okay, so V into 10k by 10 plus 2, that is 12k. So 10 by 12, V1 into 10 by 12, and what is this? This is so I multiplied by 2 here, so it will be 12 by 2. So 12 by 2, so I cancel 12, and V1 equal to 10 by 2, or V1 into 5. 5 V1 is the voltage due to V1. Okay, I think it's clear. Now coming, so so we are applying superposition theorem, right? So we have considered only V1 initially. Now we'll consider V2. We'll consider V2. So when we consider V2, we will make the second node V1 to ground. Okay. So as we can see here, and again the resistance here, input resistance is here is infinity, so there is no current in this direction, which means whatever is the voltage here, that will be the voltage here, or whatever the voltage here is the same voltage here, right, since current is 0. So what is the voltage at this node? This is 0. Okay, since this and this node is ground, this node voltage will be 0. Why? Because the op amp is ideal, input resistance is very high. Okay, so in effect this is like connecting to ground. Okay, similar to connecting to ground. So what is this configuration? This configuration is a inverting amplifier, right? So what is inverting amplifier gain? It is minus RF by R1. So if this is RF and this is R1, so what is the gain? Minus RF by R1. Okay, so what is V02? V02 equal to the voltage V2 into its gain. So V2 into minus 10k by 2k. So V2 into minus 10 by 2. Okay, so that's what I have written here, minus 5. So V2 minus 5 into V2. Okay, so that is the voltage due to V02, voltage due to V2, and V01 is the voltage due to V1. So at the end, the superposition theorem, what it tells, we have to add the voltage due to individual, right, individual sources. So means output due to individual sources. Okay, so the total voltage V0 due to V1 and V2 will be V0 equal to V01 plus V02. That is like V01 is 5, right, 10 by 2 into V1. So and V02 is minus 10 by 2 into V2. So it's like V1 minus V2 into 10 by 2. Or V1 is 6 volt, given 6 volt, V2 is 4 volt into 10 by 2 is 5. So it will be equal to 10 volts. So the output voltage of this difference amplifier will be 10 volt. So that is, so this is how we can solve this difference amplifier circuit, op amp based circuit. It's very easy. We just need to apply the superposition theorem. Again, if there are number of sources, means we can then also we can apply the same procedure. Like if I have under resistance here and under resistance here, I have applied some V3 here, V4 here. You take it individually, it will be more easy. Or else we can also, in another way, we can also like solve it by applying nodal analysis. You would have studied that you can take these two nodes, node 1 and node 2, and we can apply nodal analysis. So that is also possible, and that will be also much easier than the superposition theorem. If number of voltages is large, the best method is to use this nodal analysis. So again, applying KCL, that's it. Okay, so that is about the fifth question. Let me check if anyone has entered. And okay, okay, I have added them also. Okay, so that's about the fifth question. We will start with the sixth one. Okay, the sixth question is determine the output voltage of the amplifier shown below. So I think since we have solved summer and difference amplifier, this will be much easier. This is a the coming two question is based on the inverting and non-inverting configurations. So the first configuration is, as we can see here, it's an inverting configuration, right? Inverting amplifier. That is the voltage 100 milli. Someone has entered. Let me check. Okay. Okay, sorry for the inconvenience. Okay. Okay, so this is an inverting configuration. So the question, it's a direct question. Determine the output voltage of amplifier, right? So a 100 millivolt is connected to this configuration, and see the resistance. This is the R1 resistance, and this is RF. So what is the gain of a inverting configuration amplifier? It is equal to minus RF by R1. Okay, RF is 20k and R1 is 2k, and gain is minus, since it's inverting configuration, so it's minus 10. The gain is minus 10. So we just need to multiply the input with respect to the the gain. So we'll get some 100 milli into 10. So it will be 1000 millivolt or 1 volt. Okay, so this is simple configuration, simple inverting amplifier configuration. So that is solved here. So here we have solved, like we find the current through, again the first question similar to this third question. We have found what is the current through this feedback resistance I1. So the same current I1 will be flowing like this, right? So what is the voltage here? It is voltage here is 0. Since this is ground, this will be ground. So what is the current I1? 100 milli by 2k. So I got I1 as 50 microamps, that into the resistance 1 volt. Same. So or the first the method I told earlier, that is find the gain into the input voltage. So that will be 1 volt. So it's a simple question. Question based on inverting configuration. Let me check anyone has. Okay. Okay. Okay, so a few people have sent messages, so I will come to that. Okay, since we will complete these 10 questions and we will come to whatever questions being shared with that with me. Okay. So coming to the 7th question, determine the current flowing through the load ZL. Okay, flowing through ZL kept at the feedback of amplifier shown below. So as we can see here, this is a configuration, non-inverting configuration, similar to the previous one was inverting, and this is a non-inverting configuration. So how to find the load current through the feedback impedance or feedback, whatever the load has been kept at the feedback. So this is IL. So how we will find? So as we can see here, at the non-inverting terminal we have applied 1 volt, right? So again, since the input resistance is infinity, the voltage, whatever is the voltage here, the same voltage will be replicated here. So what is the voltage here? It will be plus 1 volt. So with respect to this ground, so how the current will flow? The current will flow from this positive polarity to ground, right, in this direction. So say current I1. So this is the current. So what is the value of current? The voltage across this resistance by the resistance. So 1 by 5k. So this is I1. So what is since there is the current in this direction is 0, what is IL? IL will be just negative of this I1, so minus I1. So it will be 1 by 5k. That is the current IL. Okay, so that is what given here. It is 1 by 5k is minus 0.2 milliamps. Okay, so this is the question 7th. I guess it's clear. Coming to the 8th question, the question is determine the output of op-amp circuit shown below. So here 2 op-amp circuit is there, 2 op-amps are there, or op-amp amplifiers are there, which has been cascaded. So as you can see here, the first amplifier is a inverting amplifier, right? Inverting amplifier. And the second is like input is given to the plus node, so it is like it is actually a non-inverting amplifier. So it's a non-inverting amplifier. So how to find the output? Simple method is like find the inverting amplifier gain, non-inverting amplifier gain. So say if it is G1 and this G2, the net gain will be G1 into G2. Okay, so this is the net gain. So what is the output? V0 equal to input into the net gain. So V in into G1 into G2. So this is the net output of this amplifier. Okay, so initially, both method has been discussed here. So first method is like, first we will find output V01 due to V in. Okay, so what is V01? Since this is an inverting configuration, V0 equal to V in into minus Z2 by Z1. So minus V into Z2 by Z1. And since it has been given, see Z1 equal to 2Z2. So on applying that, V01 will be equal to minus V in into 1 by 2. Okay, so that is V01. And what is the output of second configuration? Since it's a non-inverting configuration, whatever is the input here, that into 1 plus RF by R1, right? So V01 into 1 plus Z4 by Z3. So what is Z4 and Z3 is being given here. So Z4 equal to Z1 and Z3 equal to Z2. So substituting that, we will get 2z2 by z2. So it will be v in into means v01 into 3, v01 into 3. So v01 is v in by 1 by 2, right? So on substituting that, we will get minus 3 by 2, since v in is 1. Since v in is 1, we will get v in v0 equal to minus 3 by 2. Okay, so the other method is the one that I explained first, that is the gain of first amplifier into gain of second amplifier, that into V. So what is the gain of first amplifier? That is inverting configuration, so minus Z2 by Z1, and gain of second amplifier is 1 plus RF by R1, so 1 plus Z4 by Z3. Substituting all the values given, we will get V0 equal to minus 3 by 2. So it's a direct question, you can easily solve it. I guess it's clear from the question itself. Okay, so that's all about the 8th question. I think it's clear. Coming to the 9th question, determine the transfer function of op-amp circuit shown below. Okay, so the question is to find the transfer function of the op-amp circuit. So let us see how the circuit has been given. The circuit is like it's a combination of resistance and capacitors. So it's either a integrator differentiator configuration. So it will be a circuit or system which depends upon the frequency, right? So that's why it has mentioned like to find the transfer function of this op-amp circuit. Also the values of capacitance and resistance has been given. So how to find this? It's easy. We have to just initially find the transfer function. So for that, what is V0 by V, right? So for that, when we look into this circuit, it is similar to an inverting configuration, right? So this is one impedance, say Z1, and this is another impedance, say Z2. So what is the gain of the amplifier? It is minus Z2 by Z1. Okay, so how to find the transfer function? Transfer function is, say T of S will be equal to output V0 of S by V in of S. Okay, so this is actually gain, right? So it is like minus Z2, say if Z2 of S, it depends upon frequency. So Z2 of S by Z1 of S. So we have to find what is Z2 and what is Z1. So that is what we have to do. So that is what I have written here. So since it's a non-inverting configuration, we need to find Z2 and Z1. So as we can see here from the question, like what is Z2? Z2 is the impedance due to this capacitance and RF. Since this C and RF is parallel, so it's like solving it's like two impedance kept in parallel, right? So what is impedance across C? That is 1 by SC, right? 1 by SC, and due to RF is RF. So what is the net impedance Z2? Z2 will be equal to 1 by SC into RF by RF plus 1 by SC. Okay, similarly what is Z1? Z1 is this impedance, right? So 1 by SC and resistance R2 kept in series. So what is Z1? Z1 will be equal to R2 plus 1 by SC. Okay, we just need to substitute in this equation. Okay, so Z2 of S by Z1 of S. So we just need to substitute that equation here. So Z2 of S is, as I mentioned, on solving we'll get RF by S into C RF plus 1, and Z1 will be equal to, like, this is Z1 that we told, like, so I just took both terms to have same denominator, so SC into R2 plus 1 by SC. So I just substituted this in transfer function T of S, V0 of S by V in of S, Z2 of S by Z1 of S. On substituting, we will get SCRF by, like, on substituting both this and this, we will get SCRF by SCRF plus 1 into SCR2 plus 1. Okay, so what I did is, like, I just took CRF from both input. So S by S plus 1 by CRF into S into R2 by RF plus 1 by CRF. So I just took CRF from both the terms outside. So I guess there is a mistake. I just we need there will be one CRF also here. Okay, so there's a mistake here. Okay, there will be one more CRF here, and CRF means C into C is 1 micro into RF will be 10K. So it is like this milli, 1 milli, so it is 10 milli, so 10 milli. Okay, so this 10 milli, this K value will be there definitely. So this is the transfer function. Okay, so this is the transfer function. The only difference is like there will be some 10 milli here, a constant also is there. Okay, so which I missed here, CRF. Okay, so this is the transfer function that has been asked. So what we did is like we find, since this is an inverting configuration, we find Z2 of s by Z1 of s, that is the gain. So we find in separately what is Z2 and what is Z1, and we substituted here. Okay, we substituted here and we got this transfer function. Okay, okay. The next question is determine the same question. See, same question. Determine the stability of the op-amp. So it's pretty much straightforward. Like there is only one 10 milli value is there. That's it. But from this transfer function itself, we will get what is the stability, right? What is the like we just need to find whether the poles lies on the left hand side of j omega x or right hand side. That's it. So from here itself we can find like what is the poles. One is -50 and poles due to this is -25, right? So if we plot it, both will be in the left hand side, -50 and -25. So definitely that is stable. Okay, so that is the answer. So there will be 10 milli here. Okay. Okay, so the poles is -50 and -25, so it lies on left hand side, so the system is stable or the circuit is stable. So this is all about today's questions. So keep in mind we have discussing all the problems related to the concepts taught in week 1. Okay, week 1, week 2 and week 3 will discuss in the coming weeks. That is what we have been asked to discuss the all the portions which have been taken in week 1. Few questions based on week 1, and that must be helpful for you to solve the assignment of week 1. Okay, so that's these are few questions that I have found out which will be helpful for everyone. Okay, so that's all the questions. So if you have any doubt regarding these questions, you may please raise. You may please switch on your mic and you can ask me. Okay, I will do one thing. Many questions has been asked. I will check some of the questions asked in the message. Sir, will you discuss week 2 assignments questions? Actually, it has been said like we should not discuss any questions which has been posted in assignment. We should not discuss. That is what the instruction given. So I can't discuss any questions given in the whatever the question has been given in the assignment, we cannot discuss. So I'm sorry for that. I can't discuss any questions which is being given us in assignment, even in 1, 2 or 3, whatever. So I'm really sorry. I guess my mic was on. If like maybe there is some issue with my network, that's why you didn't hear. But don't worry, we will be posting this entire session, that 2-hour session, in YouTube, and that link will be shared with you, so you can listen in that. And if you want me to again like explain any one of the questions, I will definitely again explain that. Please let me know that. Please discuss questions based on Bode plots, gain, bandwidth product, and loop gain, sir. Because there is no time for solving. We can, as I told, first thing that this session is just for week 1 based whatever has been taught in week 1, we have been asked to discuss only that. Second thing, we should not discuss any questions related to the assignment. Okay, 8th question, sir, where we see whatever the recorded means this has been recorded and this will be posted in YouTube channel, and the link of that YouTube channel will be shared with you. Okay, question 4, please repeat. I will repeat 4th question. Okay, it has been given us to repeat the 4th question, so I will repeat that. I think, I don't know who has been. Okay, Hemangi has asked me to repeat the 4th question, and also Bhagyashree has asked me to repeat the question 1 and 9. Okay, I will do one thing. I will repeat 4th, 1st and 9th question. Okay, because on their request. I guess my my audio is means I'm audible, I guess. So I will repeat the 4th question. The 4th question is like, it's actually a continuation of the 3rd question. Okay, 4th question is continuation of 3rd question. The 3rd question is to question is like, consider an op-amp based summing amplifier shown below. So op-amp based amplifier is shown here, and the values of each components R1, R2 and RF, and also the input voltage V1, V2 all has been given. Okay, the values has been given, and the question is to determine the current through feedback resistor RF. So that was the 3rd question. So what we did is, like, so like since the op-amp is ideal, what is the current through RF? See, this current through RF is IF3. So since op-amp is ideal, the voltage here, whatever is the voltage here, that is the voltage at this node, right? So 0 volt. So, and there is no current in this direction. So what is IF voltage current through RF? The current through R1 plus the current through R2. This is the net current IF, I1 plus I2. This is the net current IF. So IF equal to I1 plus I2. Okay, so what is I1? I1 is, since this point node voltage is 0, what is the current through R1? So what is the current through R1? V1 by R1. That is the current I1. So I1 is V1 by R1. So V1 is 4 volt, R1 is 2K, 2 milliamps. What is I2? I2 is the current through R2. So what is the voltage across R2? V2 by R2. So that is what written here. So I2 equal to V2 by R2. V2 is 2.5 and R2 is 5K. So we will get 0.5 milliamps. So this is the current I1 and I2. And what is current IF? IF is a summation of I1, right? I1 and I2. So this is IF. So by KCL, the current, this current plus this current will be equal to IF. Okay, so IF equal to I1 plus I2, it is 2 milliamps, 2 plus 0.5 milli. So this was the 3rd question. So based on this, we have to find, like, the next question is a connecting question to this. So 4th one is determine the output voltage of V0, determine the output voltage V0 of this summing amplifier. Okay, so it's a direct question, like based on 3rd, we can directly find. So since the current through RF is IF, okay, since current through RF is IF and it flows from this direction, right, from this direction to this direction. So the drop will be like plus minus. Okay, so what is the voltage V0? V0 is the voltage at this node with respect to this ground. Okay, this is V0. So so what is the polarity? So like, for example, if the voltage across RF we mentioned as VRF, so V0 will be just reverse of VRF, right? So V0 will be equal to minus VRF. Since this point to ground or this point to this point, that is a voltage, sorry, not this point to this point, whatever is the voltage, that is VRF. So we will find what is VRF. VRF is the voltage across this resistance RF. So the current through RF is IF, that into RF, that is the voltage VRF. So what is IF? That we found in the previous question, that was 2.5 milliamps, right? That is 2.5 milli, that into RF. RF is the given value is 5K, so 5K. So we will get, I guess, it is 12.5 volt. So this will be the output voltage V naught. So this is the output voltage V naught. Okay. So that was the fourth question, and someone has asked me to repeat first and ninth question. So let me check the first question. So, okay. So first question was determine the poles and zeros of the following transfer function. The question was direct, like whether to find poles and zeros. Okay. So we know from the theory itself what is the poles. Poles is the values of s at which the denominator equal to 0. Values of s at which denominator equal to 0. So we know when this denominator will become 0, when the value of this term is equal to 0, or when the value of this term equal to 0. So what is the value of s at which this term equal to 0? That is s equal to at 2, and this is s at equal to minus 4. So this will be the poles of this transfer function. And what is the 0? What is 0? 0 is the values of s at which the numerator is equal to 0, right? So what is the value of s at which the numerator is 0? The value is like s at s equal to minus 3, right? Minus 3 plus 3 equal to 0. So the value s equal to at s equal to minus 3, it will be 0. So minus 3 is the 0, and 2 and minus 4 is the poles. Okay. Okay. So that was the first question we discussed. So that's what given here. Okay, I think that's clear. And the other question that the student has asked me to discuss is ninth question. So I will just repeat what was ninth question. Okay, the question was to determine the transfer function of op-amp circuit shown below. The question, wait a minute, someone has entered, I guess. Let me admit them. Okay. Okay, so let me discuss ninth question, which the student has asked me to discuss. So determine the transfer function of the op-amp circuit shown below. So it has been given as an op-amp based circuit where there are capacitance and resistance being connected. So how to find the transfer function? The transfer function is like T of s is equal to the output Laplace transform of output V naught of s by Laplace transform of input, right? So V in of s. So this is transfer function. So this is like it is similar to the gain, right? V naught by V. So what is the s domain of that gain? That will be equal to T of s. So how to find that? So as we can see here, this is an inverting configuration, right? Like similar to this. So Z2 is the network due to resistance RF and C kept in parallel. This one. And what is Z1? This is like resistance R2 and C kept in series. This is Z1. Okay, so since this is an inverting configuration, what is the gain? Or V naught by V in? V naught by V in is Z2 by Z1, right? Not Z2 by Z1, minus Z2 by Z1, since inverting configuration. So we just need to find what is Z2 and what is Z1. Okay, so what is Z2? Z2 is the impedance when RF and C is kept in parallel, right? RF and CF. So let me clear this. Z2 is this one. Okay, so C and RF kept in parallel. So 1 by CS kept in parallel with RF. So what is the value? Z2 will be equal to RF into 1 by SC by RF into RF plus 1 by SC. So this is Z2. And what is Z1? Z1 is this impedance R2 and C kept in series. So 1 by CS, right? This impedance. So R2 plus 1 by SC. This is Z1. So we can find V naught of S as Z2 of S by Z1 of S. That's it. So that's what written here. Z2 of S equal to this term RF into 1 by SC by RF plus 1 by SC. On reducing it, we will get RF by SC RF plus 1. Okay, Z1 of S as R2 plus 1 by SC. Again by reducing, we will get this term. And T of S equal to Z2 of S, Z1 of S. Just need to substitute these two in this equation. We will get like this. Okay, so as I mentioned, there is a mistake. There was a mistake in this on takings. What I did is I just took CRF from both the end. So there will be CRF will be there. Okay, one CRF will be there term. Okay, include it here. Okay. Okay. So CRF is taken from both the term, right? So that's why one CRF extra CRF will be there. Okay. So what is C into RF? C is 1 micro into RF. It is 10 milli. So there will be a 10 milli term will be there. Okay. So this is the transfer function. We just substituted Z2 of S and Z1 of S. We just substituted in it, and we just reduced it, and we got S transfer function T of S as S by S plus 50 and 2S plus 50 into 10 milli. So in next question it is just to find the stability. Finding stability is just to find where the poles lies. Here the pole is at what? The pole is at minus 50 and at minus 25. Right. So these two lies on left hand side. So it is actually the circuit is stable. That's it. So that's about the 9th question. I guess that's what the student asked me to explain. Okay. Okay. Poovarshan has asked me to discuss 8th question. I guess he is here itself. Okay. So I will do one thing. I will discuss the 8th question. Okay, 8th question is a direct question like determine the output of op-amp circuit shown below. Okay, so an op-amp circuit is being shown here, and we need to find the output voltage, right? So as we can see here, it's actually two amplifier cascaded. So like there is one amplifier here. This is inverting amplifier, right? So input given, and that is output V0. It will be equal to Vin into minus Z2 by Z1, inverting configuration. And what is the next op-amp? This is the next op-amp, and not op-amp, next amplifier. So this is like the output of this is given as input to second, right? So it is like V01 given as input. So what is this configuration? This is actually a non-inverting configuration. So what is the gain of non-inverting configuration? It is 1 plus the feedback resistor by this resistance. So 1 plus R of by R1. So 1 plus R of is Z4 by Z3. So this is the gain of the non-inverting configuration, that into the input V01, right? So that will be V0. Okay, so what is V01? V01 from previous, since this is an inverting configuration, we can just write that like Vin into minus Z2 by Z1. That is V01, that into this term, that is 1 plus Z4 by Z3. So this is the output voltage. So we just need to substitute each value, like it has been given consider Z1 equal to Z2, Z3 equal to Z2, Z4 equal to Z1. We just need to substitute it, and V0 is also given, so we'll get what is V0. So that's what we have done here. Like initially I have found what is V01, then what is V0. V0 is V01 into this term. So on substituting this, we will get minus 3 by 2 volt. This is one way. The other way is like just we know, like we have two system. Okay, we have two system. It has gain, first system has gain G1, second system has G2, and it is being cascaded. We have input is V1 and output is say V0. So what is V0 in terms of say Vin? So V0 will be equal to, so we need to find V0 into the net gain of the system. Net gain of the system, say G. So G into Vin, that is what V0. So if two system is cascaded, what is the gain? Net gain G. G will be equal to G1 into G2. Okay, so here the G1 is like in gain of inverting configuration, G2 is the gain of non-inverting configuration. Inverting configuration gain is minus Z2 by Z1, right? So minus Z2 by Z1, And what is G2? G2 is Z4 by gain of non-inverting configuration. So this into 1 plus Z4 by Z3. Okay, so if we substitute it, we'll get the same. See, minus 3 by 2. So this is about the 8th question, as Puvarshan has asked. Okay guys, I'll just check some other questions. Question 1, so I joined the course yesterday, so I get extra time for, so can I get extra time for week 2 and 3? See, actually I'm just a TA. My duty is to explain the questions related to each week. Like this week I'll be discussing about the questions related to week 1, and next week I will be discussing about the questions related to week 2. But it will be totally different from the assignment questions given. Okay, we can't discuss any questions which is being posed in assignment. We have been strictly told not to discuss. So pardon me for that. So previous class का recorded का link आपसे पे डाल see this whatever the class has been taken now, that is recorded, and I will be posting in YouTube channel, and we'll share that link. Definitely it will be shared from NPTEL side. Okay. Puvarshan explain question 8. So I have explained Puvarshan the 8th question. If you want again, please let me know. Okay. I'm sorry. Sir, explain. Shekhar has asked me to explain the question 6th. Okay, so I'll explain 6. See, actually, while I just hosted this meeting, they mentioned like it is only for 1 hour. So if by chance this meeting gets over, you can rejoin through the same link. Okay, I will also rejoin that. So and if I have not, means like if I have not answered any of the questions that you have posted, you may please again post that questions in that. So so I will go to Shekhar. He has asked me to explain question 6. I will explain that. Okay, so where was the 6th question? Okay, the 6th question is this one. No, not this one, sorry. This is the 6th question. It's a direct question. Question is to determine the output voltage of the amplifier shown below. So this is an inverting configuration, right? So I have an inverting amplifier given. This is an inverting configuration. Okay, so V0, Vin. So say this is R1 resistance, is RF. So what is V0? V0 equal to minus RF by R1 into Vin. Pardon me for my bad handwriting. I am trying with my mouse. So okay, anyway, this is the output V0 minus RF by R1 into Vin. So how we find this? This just like we'll find what is the current flowing through the feedback. Like if this is the current flowing through this feedback, say IF, we'll find this IF, and IF, since it is flowing in this direction, this plus, this minus. So what is V0? This is the voltage across this resistor, right? Since there is no current in this direction, 0 ampere, the voltage, this point voltage and this point voltage will be same, right? So this point voltage is 0, so this voltage will be 0. Okay, so what is the voltage V0? V0 is voltage between this node and the ground, that is 0 voltage. So it is similar to, this voltage is similar to this point and this point. Okay, so what is V0? V0 is IF into this. So since the polarity is just opposite, V0 will be equal to minus IF into 20k. Okay. Okay, so V0 will be equal to minus IF into 20. Why? Because since the current is flowing in this direction, this will be plus, this will be minus. And what is IF? Since there is no current in this direction. Okay, so whatever the current is flowing from this input to this node, that will be flowing in this direction. Okay, so since this voltage is 0, what is this current? Say I1. What is this current? Current will be this point node voltage minus this point node voltage by the resistance. So 100 milli minus 0 by 2k. So that is 100 milli by 2k. So that is I1. So that is I1. So I1 equal to 100 milli by 2k. Okay, so we will get 50 micro. So this is actually, this is what? This is IF. So what is V0? V0 will be equal to minus IF. So minus 50 micro into 20k, right? 20k. So we will get whatever, I guess it's 1 volt, right? 1 volt. Okay, so it's actually an inverting amplifier. That's it. Okay, so this is the 6th question, as the student has, student has asked. Okay, Jnanashekhar has asked about question 6th. Now, Satish Kumar, sir, explain once more QU questions. Q questions. Can you, sorry Satish, can you explain which question? I just mentioned that, I just could see QU question. Suraj has asked, sir, explain 7th question. I will explain that. Before that, Ritu has asked me, sir, share the link of previous class, please. See, this is the first class. Okay, Ritu, this is the first class. The previous 2 class, I guess, the class which was taken last 2 weeks, right? So actually for analog circuits like this course, we have 3 TAs including me. So there will be 3 different sessions, but we 3 like last 2 sessions and myself will be dealing with the same week questions, like week 1 questions or week 1 the syllabus. So that too link will be shared from the NPTEL. Even whatever we have discussed now, that will be also shared with you from the NPTEL side. Okay, so don't worry about that, all 3 will be shared. Okay, so we'll go with the question asked from Suraj. Sir, explain 7th question, we will explain that. Okay, 7th question is determine the current flowing through the load ZL kept at the feedback of amplifier shown below. So okay, so the question is to determine the current flowing through ZL. ZL is like some load, okay, some load kept at the feedback of this amplifier. So this is actually a non-inverting amplifier, right? It's a non-inverting configuration. The input is given as 1 volt at non-inverting node, okay, at this node, and we need to find what will the current flowing through ZL. That is a question. So since we know, again, always since it's not mentioned anywhere that the op-amp is non-ideal, this is ideal. So if it is ideal, what is the resistance here? The resistance here is infinity. So whatever there is no current, 0 ampere current, which means whatever voltage is here, the same voltage will be at this node. So this like the virtual ground constant, same thing. So here 1 volt, which means here also 1 volt. Since this is since it's mentioned 1 volt, this polarity is plus, right? So the voltage from this node to ground is 1 volt. So from here to here it is 1 volt. So in which direction the current will flow? The current will flow from the positive to negative polarity, right? So the current will flow in this direction. Okay, so this is the current direction, say I1. So what is I1? I1 is the current flowing through this 5k resistor. So what is the voltage across 5k? It is 1 volt, right? So 1 by 5k. So this is the current flowing through 5k. So this is I1. Now since there is no current flowing into the op-amp, so this is 0 ampere, right? So what is the current IL? IL is like, according to KCL, the sum of current at this node is equal to 0, right? So this current is opposite to I1. So what is IL? IL equal to minus I1, which means actually the current is not flowing in this direction. Actually the current is flowing in this direction. That's why the voltage drop is plus minus. That's why we will get a V0 equal to IL into ZL. Not means the polarity will be same as input, right? That's why we are getting like that. So IL equal to minus I1. So what is I1? 1 by 5k. So I guess it's like 0.2 milli, right? 0.2 milli. So that is that is all about 7th question. So I guess it's clear. It's clear. Suraj, it's clear, I guess. Satish Kumar, you have asked me to sir, explain once more QU question. I didn't understood what is QU. Okay, Satish Kumar is not here, I guess. So anyway, so I guess I have answered almost all. Sir, will you discuss week 2 assignment questions? No, I can't. We are asked not to discuss the assignment questions. Sir, आवाज नहीं आ रही. Actually my mic was not off actually. Maybe some internet issue. I'm really sorry for that, but this video will be recorded. I mean, the video is recorded and it will be uploaded in YouTube link. You can go through that, and if you have any doubt, you just post in that YouTube channel. I will just reply to that. Please discuss questions based on board reports. No, I can't. We have asked not to do that. Yeah, sure. Equation given assignment means I didn't understood that. Which week 1 questions? Week 1 questions or week 2, 3? First week is, I think it's similar to our current right, same. Can you please, we have asked not to discuss any week 1 assignment questions. So can you explain anyone? Yeah. You mean like the questions which is similar to the questions given in the assignment, right? It's not exact. I think it's similar, right? For example, I guess such questions has been asked, like determine the poles and zeros. I think the similar question is being asked. So how to say in that assignment questions, maybe I have also gone through the assignment questions. So they have asked about how to find the poles and zero. Again, we can get it by solving numerator and denominator, similar to this. And again, similar such a question is there, right? But maybe the order is less. It is pretty much simpler than this. So we can again find the poles and zeros by equating numerator and denominator to 0, and we will mark it on the sigma and j omega plot and find where this whether it is stable or not. Again, the same question. Actually the same, just a change I have just twisted so that it will be easy for you. I think there are summer based questions, right, in the assignment. So in that questions, I guess there are more than one input voltages. That's it. So here not more than 2 input voltages are given. So that's why I just initially I just explained. So how to, like, this is the question, that's how to find. So for example, if there are more than, sorry for that, I'll just clear it. See, like if there are more than two input, like there are 4 input, how to find that? Like V3, V4, the resistance is R3, R4. Like I think similar question is there. I think it is non-inverting configuration, that's it. Minus plus some non-inverting configuration has been given, something like that. So how to find the voltage when the number of voltage signal is higher, number of voltage signal is more. So it's a direct thing. Like since the non-inverting terminal is 0, the same voltage will be repeated here 0. So how to find the output? V0 is the current into RF. So just find the net current due to each voltages, like I1, I2, this I3 and I4. How to find each current? You just like voltage by this resistance, because this node is 0, right? So V1 by resistance, V2 by this resistance, V3 by this resistance, and V4 by R4. Sum it, that will be IF, that into RF will be the output voltage. So that is, I think, I have seen it, it's similar to that question, right? Number of voltages, input voltage is higher, so just need to substitute that. Okay. Also, there is one differentiator, I don't, difference amplifier, I don't remember, but if there is, we can, the easiest method is to apply such a superposition theorem. Okay, so we can, you can easily solve it. Also, I think there is non-inverting configuration amplifier is there. Inverting, similar to this inverting and non-inverting. It's direct questions, and the only question they have mentioned is to find the current through feedback. Again, the same. If you solve these two questions, it will be it is similar to that, right? So it's again direct. I think such a question is not there. Such a question is not there in the correct. Any other questions which is not, like which any portion which I have to stress, you tell, like these. I think all the other questions you can easily map from this. Also, see last 10th question, 9th question. I think in the assignment it is much simpler than this, right? Much simpler than this question. So I think you can easily map from this. See, I'm sorry, I cannot tell or mention any of the questions in the assignment, that's why. But based on that question only, I have made this, so it will be easy for you. So if any part is missing, means you tell, we can discuss. Yeah. Similar, no, I can't comment on that. I don't know whether same question, such questions will be there in the final exam. I don't know. This, whatever questions we have posted, it is similar to, or the core content we have discussed. That's it. So we can expect only this, right? What else? Like if the order is higher, the way of answering is same, right? The way of answering the question is same. So I think we can expect similar questions, right? Yeah. Okay. Shubham Gauri, actually sir, tomorrow is the last date of submission of second assignment, and in previous class question related to first assignment already discussed. Yeah, that's correct only, but we as I told, like we are 3 TAs. We 3 has been asked to discuss only first week questions today. From tomorrow, I think next week the next 2 will be second assignment. So that is what being mentioned. So I can't discuss second assignment questions. I'm sorry. Sir, previous class class share link. Sir, share today's lecture link I will upload, and I will share the link. Not it will be shared by NPTEL. I guess if they will share this week, or else I will just mail them. Many students are asking for the link, so that they will definitely share. I think they will share only after my this today's session. As I told, there are 3 TA. So first, second, third, all 3 over means at a time they may be posting. all three lecture means all three this lecture video link, maybe due to that, so they will share, so share it. So the final exam will be MCQ question or writing, I think it may be MCQ, I don't know. Mostly it will be similar. I think you people would have okay, anyway, if you have seen some gate exam questions, that is also MCQ, right? So mostly it will be like that only. Sir, explain 7th question. I have explained it. I think all other questions I have answered. So this session will be till 9 o'clock. If you have any doubt, please let me know. We can discuss or also they will also share like whatever PPT I have made, right? I have shown the PPT, so this will be also shared. This will be uploaded in a Google Drive link, and that will be also shared with you, so it will be easy for you to check the questions and how it is being answered. Okay, so that will also be shared by NPTEL. Sure. I understood. Okay, so the thing is like, correct, good question. So I'll just write. So like if there are two feedback, we need to find which feedback is more, like which is dominant. So that will decide whether it is positive or negative. Like if I have an amplifier like this A, and this is beta 1, and this is beta 2. So like one is plus and one is minus, so V in and V naught. So what is the net gain? Net gain, like due to one if it is positive feedback, it is like A by 1 plus A beta, right? Now 1 minus, like if it is positive feedback, it will be minus, right, beta 1. If it is plus, it will be somewhat like this, plus A beta. Okay, so the net gain will be like this. So it is similar, like if it is positive feedback, it is like 1 a by 1 minus a beta, beta 1, and if it is negative feedback, it will be like a by 1 plus a beta, right? So when combined, when both are there, it will be somewhat like this. If it is solved, it will be somewhat like this. So a by 1 minus a beta 1 plus a beta 2. So a beta 2 due to negative feedback, whatever given here, and minus a beta 1 due to positive feedback. So as we can see here, so which feedback value is more? So I just rub this. Okay, so if say I can again reduce this as a by 1, it's like 1 plus into beta 2 minus beta 1, right? You can write like that. So beta, so like beta 2 is higher, okay, beta 2 is greater than beta 1, the denominator will be like 1 plus, the polarity will be plus, so it is negative feedback. And if beta 2 is less than beta 1, okay, so it will be minus, so it will be positive feedback. So the thing is like if an amplifier is having both feedback, positive and negative, we just need to find which feedback factor is higher. If positive feedback factor is higher, which means automatically the system will go to the positive feedback, the entire system will be positive feedback. And if it is if the negative feedback factor is larger than positive feedback, then definitely it will go to the entire system will be a negative feedback system. That is how we decide whether if there are two feedbacks, whether it is positive or negative. I guess it's clear. Okay. Here itself we can write example, right? Like for example, you want op-amp based example. Okay, so like it's simple, right? Like I have minus plus, this is a negative feedback, and this is positive feedback. Okay, so like say this is R1, R2, and this is R3, R4. Sorry. So if I just, so this term like R2 by R1, okay, this term R2 by R1 results in negative feedback, right? This is negative feedback term. So say this is beta 1, and this term like this is V0 and this is Vin. Okay, so if this term is like, what is the gain? What is the feedback factor here at this point? This point is like V0 into R3 by R4. So R3 by R3 plus R4. So this is beta 2. This is beta 1. So if I have selected the resistance and resistance R1, R2, R3 and R4 in such a way that beta 1 is greater than beta 2, definitely it will be negative feedback. That's it. Like if R2 is 10k, R1 is 1k, so beta is 10. Okay, and if say R3 is 10k and some again R3 and R4 both are 10k, it will be 5, right? So definitely beta 1 is greater than beta 2, so it will be negative feedback. Other term, we can also find some way where beta 2 is greater, like if it is reverse, 1 by R2 is 1k and R1 is 10, it will be 1 by 10, so it will be 0.1. So in that case it will be just positive feedback will be more. That's it. So it depends upon the value of resistance. So this one example. Okay. I think my screen is visible, right? I just stop that. Okay, yeah, it's visible. Okay. Any other questions? Like, we have time, enough time. Hello? Yeah, yeah. I'm audible, right? Yeah, okay. Okay. Hmm. Frequency domain means it has been given like 30 hertz, 40 hertz, right? Both you can plot both in both both frequency f as well as omega. What is there means like definitely we used to. Okay, I will write here. Okay, it's like this, right? So whether at what frequency it is getting that cut off or roll off, that is important. So whether it is in omega or f, no problem, but you can, I guess you can write in both f and omega. You have to plot in what you have you given means is it like they have given in 10 log terms, or actually it is used means usually we plot in decade, right? So usually it is usually it is plotted like in decade terms, but means like you would have seen that that graph with decade terms. But while plotting, simply for understanding plotting, I guess it is better to do in omega or f. Both is acceptable, I feel. Both is acceptable. I will check, like I will confirm it in I will confirm correctly in next class. I think in next it is regarding body plot, right? I will confirm it whether it is in body means f omega, or whether it has to be in log terms. I feel it is in f and omega only. Yeah, two both are acceptable, I guess. For what gain? In I didn't mention like. Huh. Okay. No. Poles we can't consider. Like, see, poles is like if, for example, like if t of s equal to some numerator term by some s plus p1. So p definitely pole is should be in s parameter, like not in s. That is like it must be in j omega value. That is pole. Okay, so that must be in omega terms only. I'm telling, like while plotting the body plot, if we got omega, we can even map into frequency f. That's fine. But we cannot change. We cannot say like the poles is in f. It will definitely in terms of s, right? S equal to p1. S equal to minus p1 is the pole. So what is s? It is actually sigma plus j omega. So there we have to consider omega only, not f. We cannot write like jf or f. This is not f. Log what? Log f. Why you are taking log f? Oh, okay, in x-axis. Right, this one. Yeah. Like if you got a pole s equal to some minus p1, so we can easily say at what frequency is this p1, right? We can relate this to omega and p1. We can relate, correct? We can relate from this. Now you can plot in terms of omega, right? We can directly plot in terms of omega. That is enough. Or if I got omega, you can also plot in terms of f. That is also fine. Like f is whatever term by 2 pi, omega by 2 pi. We can also plot in terms of log, if it is in log omega. Similarly, we can plot in log f. But Keep in mind f and omega has a relation, omega equal to 2 pi f. We should keep that in mind and plot. Based on that only we have to plot. That is because you would not have considered properly, like S is S and how S and P1, like how is a pole considered. It should be in terms of S or omega terms. From there you have to, if you if, like for example, if j omega equal to P1, we have got pole like this, means definitely we will take more, right? So omega equal to P1 or f will be equal to P1 by 2 pi, like you may have to take in this term, I guess. Yes. Or if you are taking a frequency, this relation you have to keep in mind. Otherwise, it may be wrong. Yeah. Ideal op-amp behave as a ideal op-amp non. Can you type? Can you type like I'll just ideal op-amp behave as a. You just type it. I just. Ideal op-amp behave as a non-linearity. Why it is? Why you mentioned like non-linear? Like if I just highlight a op-amp, is an op-amp minus or plus minus is V1 given, V2 given, and this is V out. So V0 is equal to the difference, right, the voltage across this, so V1 minus V2 into the gain, that is actually an op-amp, ideal op-amp. So the gain into V1 minus V2. So since the gain of that amplifier, like for an ideal op-amp, gain is very high, like infinity. Ideal case it's infinity, V0 will be always equal to infinity. So so that is actually so if I plot like this is ideal, huh? Linear. Okay. So actually it's linear, right? So whatever, see, gain is correct. So V1 minus V2 into A. But the thing is like gain is very high. That's it. A is very high, infinity. So output voltage is always infinity if it is open circuited. That's the thing. Like if this is open circuit, right? There is no feedback. So output V0 will be equal to V1 minus V2 into A. That is output. So so as you can see here, input into gain A, so it's actually linear. But since gain is very high, it will be always infinity. That's the thing. So that's why most of the amplifier, if we have such an open circuited circuit, if you implement that, output voltage will be this has some bias voltage we apply, like say plus 15 and minus 15 is the bias voltage. The range of this amplifier, this op-amp will be restricted within, say this is V0, if this is V0, it will be restricted within this 15, okay, plus 15 and minus 15. It will be restricted like this, somewhat like this. So whenever if there is a small difference between V1 and V2, the output will quickly jump to this one, this value. It will get saturated to 50. That's the thing. If we could have bias voltage, if we can apply to an op-amp bias voltage plus infinity and minus infinity, definitely we will get that linearity like this. You will get whatever input, that into gain, that will get. But it is not possible in ideally, practically it will be like this. It will be like this because of this saturation. Okay, so that's why most of the required. So this configuration is used as a switch rather than amplifier, right? So difference plus minus, it will either switch to plus 15 or minus 15. So in most of the configuration for getting or trying to build an amplifier, a real amplifier that will be useful, will either use a inverting configuration or non-inverting configuration. So in inverting and non-inverting, there will be feedback resistance. So there will be feedback that will result in a particular gain that we required gain. So R1, R2. So we can easily fix the gain R2 by R1 like that. So again in that case also it's linear, right? V1 into minus R2 by R1. So it's linear. Or in the case of non-linear, V1 into 1 plus R2 by R1. So again that is linear. So it's linear only. The linear is because of its Okay guys, so I think there is no more questions. I'm ending this meeting. So nice to meet you. We'll meet next week. Next week will be week 2 questions, the questions based on week 2. Okay, so we can discuss that next week. So okay, bye. Thank you. Welcome. Most welcome. Yeah. Bye.